As I mentioned earlier in this course and in the previous functional programming course, writing pure functions isn't usually that hard. You just make sure that output depends only on input, and you're really in pretty good shape. So everything comes in the front door, goes out the back door, no side doors. The harder part of functional programming involves how to glue together all your pure functions to create a complete application. And because this process often feels like you're writing glue code, especially if you're doing it from scratch, I do refer to this process as gluing, although a more technical term for it is called binding, as I note right there. And this process is what a lot of the rest of this course is going to be about. Also, as you may have guessed from the emphasis of our previous lessons, in functional programming and Scala, this binding process is going to eventually involve the use of for expressions, but we have to work our way up to that. So, just to kind of set the stage for what we're going to be working with here, let's start off with a simpler problem. So, imagine that you have two functions named f and g, as shown right here. The body of the functions doesn't matter. The only thing that matters is that they both take in int parameters right here and here, and they both return int parameters right there. And because they line up like that, a really nice thing is that you can easily connect them in a pipeline because an int comes into f and then comes out of f and then goes into g and comes out of g. You create a really nice, simple pipeline like that. So then you can write code like this and then write more code like this. So I implement the bodies here and then show that code right there. So this part right here is what I mean by binding or composing, if you want to use that term, composing multiple functions together. Now, where this gets interesting is where the type signatures don't match up. So now if we change f and g so that they still take in int parameters, but now they return a two-element tuple of an int and string, as shown in this example. If you look at this right here, you can imagine now that this is returning an int and a tuple, just like this right here. So now if that is right here, you can see that that input is not going to go into G because G takes an int, and now we're trying to put a two-element tuple into G. And so you start to see what the problem is going to be. Also, I forgot to mention one possible use case for this might be something where you're using a rules engine or artificial intelligence. So not only do you want the return value from a function, you want some sort of string that describes why the function did what it did. So that's somewhat of a common use case for this. As you'll see later, this actually has to do with debugging, and we might refer to these functions as being debuggable because we return the answer as the int right here, but we also return a string that describes again what the function was doing or why it did what it did. And I note up here, a good example might be if you're writing an application to determine the shortest route from point A to Z, a function might return a logging message that said I chose B as the next step because it was closer than C or D. So logging is another good example of where you'd use this kind of function signature. And so now here I do show the problem. So we have the int comes into F and int and string comes out of there. And now we have a mismatch here. And that int and string cannot go into G. But then you have this situation where you really want to plug the output of F into the input of G. So what can you do? So what we could do here is look at how to solve this problem manually. And to help us get started with this process of solving the problem manually, I just created some F and G functions over here. So now let's start working through how we would solve this manually. So we'll get rid of that right there. And what we might do here is we're going to call F and give it 100. That's going to be on the right side of the equal sign. And then as I show in the book over there, we're getting a tuple back from that. So I call that one F of int, and then we can call this one F of string. And these are the two values we're getting back when we call F. So you can see F is returning this integer result right there, and then it's returning the string result right there. And now you ask, well, how can we use this with G? And the way we do this manually is what you can do is when we call G, we see that we can pass in f of int into it. So we're going to get the int out of here, out of this tuple right there. We're going to pass that into G. And then we're going to have another tuple right here. So now this tuple is going to be G of int and G of string right there. So I hope you could see, I wish I could draw right here. I'd like to draw a line right from here to here. But what I'm doing is calling f right there in the first line. I get that int, and then the only thing G is going to take is that int. So I pass in that right there. And now what I have left to work with is I have the int result from G and also have the string result from F and G right there. So I show here in the book our log message might be the concatenation of those two right there. So we could say, well, log message equals F of string plus G of string. Can't remember what that's going to look like. If that looks ugly, we'll go ahead and fix it. And now the result that we're looking for is actually in this G event right there. So I will use a print line right there and say that the result that we want is going to be that G of int. That's the summary of the two int values. And then the log is going to be that log message like that. And let's save that. And again, the result is going to be 600. So what happens is we pass 100 into F. So that's doubled. So that becomes 200. So F of int is going to be 200. Then we pass 200 into G, and that gets multiplied by 3. So that becomes 600. G of int becomes 600 right there. And then the two log messages, both of them begin with a new line character as shown right there. So that's that result from F right there. And this is the result from G right there. And again, that gives us the debug information we were looking for, is that the result of F is 200 and the result of G is 600. So that's how we solve the problem manually. So in the book, I show that complete source code right here. Again, remember that this is written with Scala too, so that's why the syntax is a little bit different. But important parts here is that there's a comment right there that shows that we're interested in getting the output of F, and then we get the int from F as the input to G right there like that, and then we do the same thing that we just did up here. And so while this process works, if you can imagine if we had more and more functions over here that did the same thing, like if we had H and I and J, and if we had to keep doing this type of code right here for H and I and J, you could see that that code is going to be more and more complicated. And that's not something we really want. And actually, I could show you what I mean by that is I would copy that and paste that. So right away, you get the idea that I'm copying and pasting. And if you're copying and pasting a lot, that's probably a good indicator that you're doing something wrong. So that would be like that. And then if I had another function that was named I, then this would be I of int and I of string. That one would be I, and that one would be H, and so on. And I don't have those functions, so if I save that, you get an error message down here. But you can see the pattern here is that you call this function with some input value, and then I get an integer result from that. I pass that integer result into the next function. So again, if I could draw lines, I draw one from here to here, one from G of int here to here, H of it from here to here, and then our final result is there. And then we would also want to accumulate all the log messages right here. So again, this is a lot of manually written code. It's very prone to error, and you can also see the pattern that's emerging in this code right here. So we can do better, I believe.